Discuss a problem for longest common subsequence. So this problem is actually to find out a sequence that appears in the same relative order, and obviously that sequence does not need to be continuous in manner. For example, for these specific two strings, string 1 a b c d a and string 2 a c b d a, so the longest common subsequence for these two strings is a c d a, and you can check it out that ACDA is not in a continuous manner. So how we are going to approach to the solution? Yes, we will use dynamic programming for that. So let's start with the solution. To start with, we have to create a two-dimensional array. On one side we have a string 1 a b c d a, and on another side, on vertical line, I have another string 2. So we're creating a two-dimensional array for these, and the first thing what we do is to initialize our first row and first column with a 0. Why we are filling up with a 0? 0 means that if we do not have any character in string 2 and we are only considering string 1, that means there is a longest subsequence of 0 length exists. So that's why we are appended with the 0 for first row and same as for first column. So this is kind of a starter or a dummy row and column for that. So we'll start with each character in string 2 one by one and compare each character with all the characters in string 1. So likewise, consider string a character A in string 2 and a first character in string 1, which is A. So we'll match it up. Yes, A and A is a match, so we'll add 1 plus to the diagonal of this. So the diagonal of this is currently 0, so we'll add just 1 to the diagonal, which is 0 plus 1 makes it 1. Why we are adding it 1? That means that we are considering once we have a match of A, that means that we have at least a length of 1 LCS exists, and we are adding up to the diagonal means that we are adding all the longest common subsequence before that. So okay, let's fill up the matrix and you will get more clarity after that. Now match character A with the character B. So it's not a match, so we'll take the maximum from this 1 or a 0, or you can say from the upper side or the left side. We'll get out the maximum, and I'm just pointing out this arrow. That means from where I got this value from. So I got this value from this one, so I put it arrow. That means I'm putting just 1. Same likewise, filling up the matrix goes with the second value, which is A and C. Again, it's not a match, then I'm just putting 1 to this. That is, I'm getting a maximum value. I'm just putting a arrow also to get out from where I'm getting this value. Say likewise, I'm filling another value. A and D is not a match. Again, I'm putting 1, and again A and A is a match. Then I'm adding 1 to the diagonal. So currently the value in the diagonal exists is 0. So I'm adding 0 plus 1. That means 1. Likewise, again I'm coming to the column 2. Now C and A is not a match. So I'm taking maximum values from upper or the left one. So the upper one is maximum, so I'm taking 1 and putting a arrow from where I'm getting this value. I'm getting this value from the upper part, so I'm just putting a 1. And now I'm matching A and B again. C and B. Again, it's not a match. Now you can see the 1 on the upper and 1 on the left is same. So when these are the same, so by default I'm taking a value from the upper one. So I'm putting this arrow, upper arrow. So taking this 1. And likewise, now C and C is a match. You can see now it's a match, so at least now I have a 1 plus of diagonal, whatever the diagonal is exists. So diagonal is 1 and C and C is a match, that at least we have a length of 1 LCS exists, and adding 1 to the diagonal. So diagonal is 1, so adding 1 means it's a 2. Again likewise, C and D is not a match, so take a maximum from the left one or the upper one. The left one is maximum 2, so I'm putting down an arrow from where I'm getting this value is 2, so I'm just filled it with 2. Same, C and A is not a match, so I'm likewise putting 2, taking a maximum.